my machine. So you just have to go and call it library QCC. Okay, and then I'm setting my seed 1. Okay. So if you want to understand what QCC is what are the functions that is all available in QCC, you can just like go for help, and then you can just look here and then get a quick tour on QCC. Okay, you can make a lot of quality control charts here, QSIM charts, multivariate quality control charts. Okay, lot of things that you can make it here, and you can also like check out your binomial and Poisson distribution data as well. Okay, it's actually a kind of a very important package which is kind of used in managing the quality in both IT and ITES companies as well as in manufacturing companies. Okay, this package is kind of used in many places. Okay, and so it's very important package that you should be knowing this. Okay, so I'm kind of setting seed, and then I'm going to create a random data out of normal distribution, and then I'm just like creating a data set. Okay, if you want to see this data, maybe we can just like print it out. Yeah, so this is the data that I have created, looks like. Okay, and then I'm going to create a control chart here. Okay, so I'm just like giving QCC, and then I'm like adding the data here, and the type is xbar.1, the type of the chart. Okay, and then center, and I'm giving the title and what should be in the x-axis and everything. Okay, so I'm just like giving it and running it here. So this is how I'm getting my chart. Okay, so I'm just like zooming it for you. Actually, a control chart is a chart which helps you to understand the limits of your data. Okay, so here you have this dotted line, right? This is your lower control, and the dotted line on the top is your upper control. So when you see the values, the lower control is 9.4, the upper control is 10 point something. Okay, and then there are a number of groups. There are 100 different elements here, and then the center is 10. I mean the mean is 10, where you should be getting the line. Okay, the deviation, standard deviations, like I think I can't here see it. Okay, so I mean we have like specified this earlier. I mean, we just like specified when we're a few things when we're trying to create the data. Okay, so actually, I'll just tell you where this chart is kind of being utilized. Imagine you are working in a manufacturing company where we're just like manufacturing nuts and bolts. Okay, and always the circumference of the nut which is manufactured should be around 10 centimeter. Okay, so if you are in a quality department, so maybe you can just check and find out, okay, if it is around 9.6 centimeter, yes, you can allow it, and if it is around in the range of 10.4, around 10.3, you can allow it. So as anything above 10.4 should be rejected, 10.5 should be rejected, anything below 9.4 should be rejected. Okay, to visualize how the variation happens throughout the manufactured product diameter, people use this. Okay, so it's actually used in the manufacturing sector, or actually used in the ITES companies or IT companies. Like imagine there's time limit for completing a task. Okay, it's around 10 minutes. Okay, and then you calculate, you actually record the timing for each of the tasks the person is doing, and then and then if everything, if closing a case always it's around 10 minutes, yes, it's fine. If any of the cases takes less than 9.5 minutes or above 10.5 minutes, you have to check, okay, why it is taking some extra time. Okay, yeah, this kind of things happen. Okay, this kind of things happen. This kind of process control takes place in all the companies. Okay, everybody, any company, you name any well-established company, they'll be using this. So this is actually, that's where managers would be like looking at. Okay, so this is a very, very important chart that you should be like understanding. Okay, so just we created a small control chart. Okay, I just explain how it looks like and what is the real use of all this. Upper limit control, the control limit, lower limit control. Okay. Next, I'm just like creating another set of data. Okay, and then I'm creating a X bar chart again. Okay, so when you see this data, it's it's kind of little weird when compared to the first one, right? So you see you have few points which actually goes beyond the upper control limit, right? It is like beyond 11.5, which means there is some deviations here, which means you have to really check, okay, what is happening there. Okay, so actually this is the right method to check out the quality of the particular uh, uh, product manufactured or the process which has been carried out, anything. Okay, so and another example where we like try to create an R chart and X bar chart. So we just like created one more data with four different variables. We just have v1, v2, v3, and v4. Okay, so because we kind of replicated it four times. Okay, so we just like gave as data frame replicate 4. So we're kind of creating a normal distribution of 10 values with mean 1.37 and standard deviation of 0.05. So we kind of running it four times, so we might be getting, yes, four different variables, and all these things is kind of stored in data frame, and I'm creating an R chart for this. Okay, I'm just creating an R chart here. When I plot it, so all the values kind of like range between 0 and 0.2. Okay, okay, and my center line is around 0.1. So nothing is above the upper limit 0.22. But we didn't give any constructions here, right? We're just like asking to create a normal distribution with mean 1.31 and standard deviation 0.05. Okay, there was no limits given, so we just like got this. Okay, okay, and then we're creating a X bar chart here. Yes. Okay, so when you see the difference between the X bar and R chart, see, actually, the center line is like drawn at 1.301, which is like kind of a mean that we kind of gave already, right? And central deviation is based on the computations. Okay, it computes as a mean and standard deviation, and from that, you get your control limit in your X bar chart. Okay. Next one is NP chart. Okay, so for that I'll be like exporting an Excel sheet from my machine to into R. Okay, you can use a lot of methods to do that. So you just like have to click on import data set and then click from Excel. You can import, or you can just give read.csv because it is a CSV file. I'm giving read.csv, open bracket, file.choose, parenthesis, open close parenthesis. I'm closing the parenthesis again. So when I click this, I'm getting a dialog box open. So where I'm just going to give the path where I've stored my data. So I'm going to select data np1. Okay, which is I'm going to use it for this. And then I'm attaching this data np1. I'm printing it for you. Okay, so this is how np1 looks like. It's nothing but a list of 100 values. Okay, 5 4 3, these are the index number. You don't have to worry about this. This is the list of values. Okay, so I'm going to create an np chart. So I'm just giving qcc, and then my type is np. Okay, yeah, I got it here. Okay, and then so let's see if there is any deviation in the data, how this NP charts look like. Okay, I'm gonna import another data set with some deviated, with different kind of data with some deviations. Okay, the NP2 data. Okay, I'll just print those items. So it's kind of a similar data with 100 different values. Okay, let's see. Let's print out how it looks like. We have a few deviations which is kind of marked in red. Okay, you have 3 deviations from your upper control limit. So it says number beyond limits is 3. Okay, now I'll just show you how you have to create a C chart. Okay, I'm just like creating a importing in another data set for C chart, C1 CSV. Then I'm attaching it, and I'm just like showing how it looks like. There are only 25 values here. Okay, this is how it looks like. Okay, it's a proper defense. So I'm not explaining what the chart is about and why it is used, where it is used, what is the real purpose of it. I'm just showing you how to plot this right now using QCC package. We'll be discussing all this in your theory sessions. What is a C chart and what is an NP chart and what is the R chart, everything. Okay. Here you just like have to change the type. Okay. There it was NP, here it was just C. Okay. So you have number of groups 25, which means there are 25 different values. Okay, and then the center is 2, the deviation is 1.41. Actually this is actually this C chart is actually used when you're trying to identify the number of defects in the process, in a product or in a group. Okay, I'm not talking about a number of defective products. I'm talking about the defects. Okay, if you have one defect in a product, you can call that as a defect, and the product is defective. If you have 10 defects in a product, a very big machine, you have 10 defects, so that product is defective, right? Okay, so defects is different, defective is different. Okay. So you'll be like studying all this later. So I'm just like helping you to figure out what is this. Okay, I'm just going to plot in another C chart with defect. I mean with outliers. There were like around 100 values when you print it, and then I'm plotting it for you. So I'm just giving the types equal to C. Yeah. Sorry, I'm getting an error. Okay. C2. I think I didn't import it properly. Okay, so here I have a few out of control data, which actually like it's beyond 8 here and it's beyond 7. Okay, because our upper limit was only around 6.9 only, right? It was beyond that. Okay, so we just like looked into how we can create different types of control charts like R charts, NP charts, C charts, X bar. Okay, so we are using only QCC package here. Okay, I'll just show you how we can compute ANOVA. Okay, so ANOVA is a test actually like used to identify the association between the data. Okay, so I'm just like using the iris data set. I'm sure you should have like used this iris data set earlier. Okay, I'll just show you again. Okay, so it looks like we had 150 rows with 5 different columns explaining our which has the numbers of sample length, sample width, petal length, petal width, and species of 150 iris flowers. Okay, this kind of collected long ago. So I'm just like attaching iris, and then I'm checking is the species variable in the iris data set is a factor. Say it's true. Actually, at least one of the variable in ANOVA can be like a factor variable, a categorical variable, so that you can uh, carry out this. Okay. So I'm just like trying to check, do a block spot, and try to identify the distribution of data of petal width in different species. Okay, so when I check it, the distribution of petal width in the species Setosa, it's less than 1.5. Okay, whereas in versicolor it's around 1.5, and in virginica it's around 2. Okay, so the petal width is kind of increasing from Setosa to virginica. Okay, so I'm just like kind of creating an ANOVA test for this. Okay, so the code here you have to use AOV, which is nothing but analysis of variance. ANOVA stands for analysis of variance. Okay, I'm just like giving AOV between petal width and species. Okay, and then I'm printing my results. Okay, so here you can see the sum of squares of species and between species and petal width is 80.41. The degrees of freedom is 2. Okay, the error is 6.15. Okay, so this is the sum of squares of species, and this is sum of square of error. Okay, and then if you want to like know the your more information on the f value, you can just like go to summary and then print it, and then the f value is 960. Okay, and the significance is it's 2 power, sorry, so yeah, so this is how you get the summary values. Okay, so you will be like discussing about what is ANOVA and why it is being used, and what is it you're trying to identify in your next sessions. So I'm just right now showing you how you can compute ANOVA and how you get results. Okay, so you're just like using AOV. Okay, it's completely easy, it's very easy. So far we have discussed how we can like visualize charts of different control charts in statistic quality control using QCC package, and how you can like compute ANOVA between two different variables in a data set. Okay, if you got any questions, you can just like shoot it right now.